Welcome, everybody. This is our third installment from Gateway Chapter SCTE ISBE for what we're calling Building a Small Business in a Local Area Network. The first two installments, essentially what we've done is build a mock network, and I'm going to go ahead and share my screen now. And there it is, show screen. And you should be seeing Cisco's packet tracer tool. And this tool is a network emulation tool, so it's not real networks, and it's not a fully fledged functioning Cisco iOS image for all these mock devices. This is a somewhat scaled down environment. The idea is that it's a useful tool for teaching. About half the people or more that have been on these have seen it before in some form, so it's semi-familiar to them. I don't spend a ton of time explaining how to interact with it because it's relatively intuitive and it's the kind of thing you can get on your own and tinker with and play with. Let's talk real quick about what we did before to get everybody caught up that hasn't been here before, and then we'll kind of dive into what hopefully will be two different exercises that we'll cover today. Essentially what we've done is we built a small local area network, actually technically three small local area networks. And this fictional company, ABC Plastics Company, which I found out through a web search that there really is one, I think, out in California. So I should have guessed that somebody would have it. This does not purport or pretend to be that company. I'm not stealing anything from them, and I'm not making any money using their name. So hopefully they won't ever find this and get mad and sue. I don't think we need to worry, though. I think we're safe. So essentially what we're doing is we have three local area networks, and those three local area networks are bounded by this router 0. And each of them have their own subnet associated with it. These virtual local area networks, or VLANs as we like to call them, are numbered 192, 172, and 10. And we have three PCs, emulated PCs, living in these domains. And each of these switches provides connectivity just for that local area network. And they are all aggregated into this one switch we decided to name aggregation switch. And all three of those virtual local area networks, all three of those VLANs are trunked up to this router. And some of you may recall that this is commonly referred to as router on a stick scenario, where essentially you have a single physical link to multiple VLANs, and we use the 802.1q, IEEE 802.1q VLAN tagging functionality to separate the traffic from each other. And it essentially lets them work as if they're three physically diverse, physically separate local area networks, but only virtually so. So no surprise, we call them VLANs. All right, let's see. Let me acknowledge all these questions here so that I can make it look all special and exciting whenever I see you speak up. So I'm not purposely stalling. I just want to make sure that I can see everything and it's cool. Okay. So the next thing we did after we built these and made the connectivity between each virtual local area network work and function, where this PC, for example, PC2, could ping PC8 or things like that. After we did that in our first assignment, our first exercise, the next thing we were tasked with doing was, let me go back and look. Make sure. Did we tackle ticket 1? I don't know that we did, but I know that at least at a minimum on our last visit together, we configured our first internet configuration. So essentially we got a very small scale residential like internet connection for our small business local area network, or three virtual local area networks as it were. And we did some tinkering, we did some configuring. We configured in a way that would give us a dynamically assigned IP address as we face the internet. And we also configured it in such a way that it was every host in this network, in these three networks, when they communicated with the internet, since these were private IP addresses, this is private IP space, what we refer to as RFC 1918 space, we can't advertise these subnets or these networks out to the internet. Since we can't advertise them out to the internet, any traffic initiated by any one of these PCs that goes to the internet world, when the internet world tries to respond back, it wouldn't be able to respond back successfully because we can't advertise, hey, this 10 dot network lives over here. Hey, this 172 network lives over here. So we had to come up with a system in which we made sure that these addresses, these source IP addresses in the packets, were translated to be the single public-facing IP address as it faces out in the internet world. And it was a 24 dot, I think it was 24.217.0 dot, I don't know, 102, 101, something like that. Maybe 1, maybe 2. We will check that here in a minute to validate it, make sure we're not crazy. There it is. 24.217.0.102. That's the fast Ethernet 0/1 interface on our router. I know that because if I hover over the router in Cisco Packet Tracer, it gives me cool information like IP addresses, VLAN assignments, things like that. I can also hover over, as you might recall, hover over the actual links, the little green blinky lights that are represented here, and see that, oh yeah, that's fast Ethernet 0/1. That's facing the ISP up here. Could be an entire internet universe out there that we don't know anything about. What we do know is we get our internet connectivity from them. And everybody on this call has got to be as familiar as can be about providing internet to a place. Lots of us have business and residential customers that get this kind of connectivity in that way. And since we had just kind of turned our lab on when I loaded this file after thumbing through them like I did, it is rather apparent that at first when I hovered over the router, we didn't have that 24.217, that public address, a publicly routable address or globally unique address. It took a little while, and that's because the DHCP process, it takes a while to function. In the real world, these networks have been up and running for days, weeks, months, or years, and it doesn't require all the DHCP and MAC learning and ARP so much as it does when we first fire these up. So there's some disadvantages to an emulated environment, but the big advantage is I can break anything I want. We can experiment together, do anything we want, and it's not going to actually harm the real world, which is one of our first mandates. I'm sure everybody here is required to function in some form of at first, do no harm, right? So maintenances, troubleshooting, investigations even, we want to be as unintrusive as possible. But we get to do whatever we want here. So we can intrude all we want, we can tinker all we want, and can't hurt a thing. So we got the networks built. We got routing functioning between each of the networks or the subnets or the VLANs. You'll notice that subnets and VLANs tend to go together. They aren't exactly the same thing. A virtual local area network is really a layer 2 construct. It's about the broadcast domain in terms of MAC addresses. Everybody remembers the OSI model. We've got the physical layer as layer 1, then the data link or MAC address-like layer as layer 2, and then we've got the network layer as layer 3, which is about IP addresses as opposed to MAC addresses. But what typically happens in the universe is that single broadcast domain, that single layer 2 broadcast domain, is typically only associated with a single IP network or IP subnet. So our assignment today is twofold. We have a ticket, sort of a trouble ticket in a sense, and then if we don't take more than 2 hours, if we take less than 2 hours, which I suspect we will have another assignment with respect to, it actually is going to tie into what this ticket is telling us to do. So because the text is kind of small, I'm going to read through the instructions, so to speak, for this ticket, and we will tackle it. So ticket number 2 says the engineering department is planning to expand their LAN space to include additional network equipment. In advance of this deployment, they would like to ensure that no telnet requests can reach any equipment in the engineering VLAN, virtual local area network, from outside that space. So we are assigned with creating an access list that denies the interesting traffic out from outside the engineering IP space that is destined for the engineering IP space. So immediately in these instructions, we're talking about source and destination. And as soon as you get done building networks on their very simplest level, very early on in terms of troubleshooting or in terms of more complex implementations, like especially with regard to firewalls or load balance appliances, but even in a routing perspective, source and destination matter all the time. Even when you don't specify a source, there is an implied source of some kind. Even when you don't specify a destination, when you're making firewall rules or routing rules or ACLs, access control lists, there is an implied destination in there somewhere. It may mean everything. It may mean nothing. It just depends. But source and destination are entirely critical. And one of the things I like to tell people is when I started in my IP education, my IP universe, that concept wasn't hammered, drilled home real early for me. So it wasn't that I didn't know or have a sense that it mattered what the source was and what the destination was for the traffic, but I didn't give it the regard I maybe could have or should have until I got a little further, a little more advanced in my career. So I like to tell people right out of the gate, always be thinking for every conversation, for every transmission between machines, server to client, PC to PC, mobile device to something on the internet, there's always a source and destination that matters from both a MAC address perspective and from an IP address perspective. So again, traffic from outside the engineering IP space. So basically anything in this entire domain that I'm hovering over with my mouse pointer, trying to go slow so it shows up on your screen so it's not too jerky. So anything from out on the internet, anything from around here, anything from this VLAN, the accounting VLAN, you'll notice that's the accounting switch there, probably in very small print, which is why I'm pointing it out. Anything from the IT VLAN and the IT switch, anything coming from all of that stuff destined to this engineering virtual local area network, destined to this 172.16.0.0/24 space. So we want to make sure we're going to build that, apply it to the appropriate interface or interfaces, and then we're going to make sure to test our ACL from PCs inside of and outside of the engineering VLAN. Be certain that all other connectivity to the engineering LAN isn't affected. So we got to block anybody in the universe trying to telnet into this virtual local area network, but we want to make sure not to break any of the communications from this virtual local area network out to other VLANs or even out to the internet. Hopefully all that makes sense. At this point, I'm going to pause. Does anybody have any questions? Is anything what I'm saying too fast? Does it make sense? You missed the other labs, so it's confusing for you? Anything along those lines? Questions? I like this new universe we live in which people don't like to use their voices. They like to type and text. Although I'm not giving you my phone number, so you can't text me. Dan says it's all good, so hopefully everything's making sense. All right, thanks. Don't regard my answer as just being a plain old A. It's just me filling in the space because it makes me feel better. So, all right, cool. All right, so let's see. We've got a few more people that have joined. We've got, pardon me. All good. I'm going to switch to phone in. Okay, Steve. Okay, cool. I got Christy, Dan, Dick, Dylan, Jeremy, Len, Scott, Steve, and Steve. That's pretty good. That's the bulk of the folks that I think registered, so I think we're doing well. I want to wait just a half a second here to give Steve a chance to get his phone up and running. All right. Excuse me. So, and this is going to be recorded too, so if I'm not mistaken, you should be able to get this off of SCTE website. If for some reason it doesn't work, we can work together and sort it out, but I'm not too concerned. And hopefully I didn't even ask. I didn't do an audio check, but I think Jessica and my conversation prior to our broadcasting and pulling you into the room was pretty successful, so hopefully you folks can hear me. I know you'll let me know if you can't. So one of the first things we want to do is figure out where in general, where are we going to create this access list? So there's lots of possibilities, but somebody, okay, no worries, Steve. As long as you can type, then I think we're good to go. So can somebody tell me, of all the things on this screen, where would we probably put an access control list? Where do they typically go? You are allowed to guess too. Guesses are fine. There are no dumb answers at all. The only way we figure this stuff out is to talk it out. So please feel free to offer me a guess. Yeah, router 0. Jeremy says router 0. Steve says, yeah, on the router, dude, duh. So yeah, that's absolutely right. Technically, we could put them on switches, but it would not be considered best practice when you're performing a layer 3 function, because this is a very much a layer 3 function because we were talking about source IP addresses to destination IP addresses. You really want to put it on a routing device. Technically, the switches are capable of doing it. It's not advisable. It's not considered best practice. So the only thing that's doing any routing, that's doing any paying attention to IP addresses besides the clients, the hosts, the PCs themselves over which I'm hovering at this moment, is the router. So router 0. So we know we'll put it on router 0. So what we'll do is we'll start off by, let's just get into the CLI, the command line interface for router 0, and let's just create the access control list. we'll start there, and then we'll talk about where it might need to go, per se. All right, so I'm in the router. I'm going to use the enable keyword from my user executive prompt to get to my privileged executive prompt. Now, instead of a little less than space, I have the pound sign that says I have full control. I can do all the stuff. I am in command. Let me put this on top here so we don't lose it, and I do that to myself every single time. Okay, so I like to hit enter a bunch of times because it gives me white space and makes me think to myself I'm starting something new. It is certainly not required. So the first thing we need to do is get into global configuration mode to start creating, to craft this access control list. Does anybody remember how we get into global configuration mode on a Cisco device? Yeah, CONFT, config T. My fingers type out of habit config T, but essentially we're typing configure terminal, and I'm just using the tab key to auto-complete those. As long as the number of characters you put in add up to something unique, once you hit tab, it will go ahead and auto-complete that for you. It's just a habit I've developed over the years. So config T, configure terminal. We're in global configuration mode now. Excuse me, we have all the power. So there's a couple of different ways to do it, but because we're specifically talking about both source and destination IPs, and we're talking about something else as well with regard to what our ACL should do or pay attention to or consider interesting traffic. What else do we have besides source and destination IP that we talked about when we talked about our instructions for this ACL? Who's got a guess for me? It's sort of implied. It is not explicit. Yeah, that's exactly right, Jeremy. We need to block telnet. So because we need to block telnet, we're not just concerned about source and destination IP, but we're also concerned about destination what? I'm just staring at the question board. See? Yeah, destination ports, specifically TCP ports. It's exactly right. Protocols. You're right, absolutely right. Excuse me, absolutely right. So because we're talking about more than just, that's exactly right, TCP port 23, excellent. Because we're talking about more than just source and destination IP addresses, we're also talking about TCP port numbers. There's two different main families or classifications of ACL, standard and extended. Which one do we need here since we have the port numbers? Yeah, we need extended for sure. Dylan's correct. So let's see if I can remember how to do. I'm going to admit to you, I didn't rehearse this ahead of time, so we're going to fumble our way through it. I'm going to say IP because this is at least a layer 3 thing at a minimum. And the first thing when I hit my question mark for my context-sensitive help is access list. Sweet. So it says, hey, if you want a named access list, which could be either standard or extended, then continue typing these words. So I typed access list, actually typed ACC and hit tab, and it makes it unique enough to say, oh, you want an access list. Use my context-sensitive help, and boom, there we go. Would you like extended or standard? Well, we've already established that we want it to be extended. And then I'm going to, again, use my context-sensitive help, and it says, look, you can give it a number. Whoops. Oh, I can't click. Or if you want, use a word, any word you like, and give it a name. I think we'll give it a name, and I think we're going to call it engineering-security, EngSec. Just because we're trying to sort of secure that engineering VLAN. So it's as good as anything else. I'm bumping my mic stand, which means I know you're probably hearing that. I apologize. Again, if I do something like that and you didn't hear what I said, stop me. We'll go back. We'll double back. Easy peasy. So I'm going to say, hey, I want to create an access list, an extended access list, and we're going to go ahead and use the name as opposed to a number. We could do either, and it would function the same way. And I'm going to call it engineering security. And if I use the context-sensitive help, my question mark again, it says carriage return is what you can press here, meaning nothing left, no other keywords, no other choices. So once I hit enter, you'll notice our prompt changes from global configuration mode to, hey, you're doing a configuration for an extended named access control list, ACL. I don't like to use the term NACL. I think it sounds ridiculous. I think we're smarter than that. I also, any of you that get to know me will find I have an exceptional abhorrence for our over obsession and love affair with acronyms in the technology world. We have this obsession and we have this idea that it makes us sound smarter. It doesn't. It makes it sound like we're trying to make other people feel stupid. I hate using them. So I try to avoid them, although there are some like IP I'm not going to say internet protocol address or anything like that. But in general, you'll hear me spell these things out because we're grown-ups and we're paid enough to use the full words or type the full words. We can afford all the typing, all the strokes it takes on the keyboard. So I know I get on my soapbox about that. A lot of people are like eye rolling. I get it. I don't blame you. So, all right. So we're now in access list configuration mode. I'm not going to lie to you. I go right to context sensitive help. What can I say? So what's the thing we want to do of all the choices we have? What's the thing we want to do with the traffic? What is the traffic we're talking about? Specific source and destination addresses. We talked about protocol or port number. What do we want to do? Yeah, we want to deny. Specifically deny telnet traffic, but deny is the first thing we want to do. Absolutely right, Steve and Jeremy. So, whoops, I got all caps because I'm yelling at you. Deny. I want to deny something. Now I got lots of choices from a protocols perspective. These you don't have if we had started this as a standard ACL, we would not have that. We would just have a much shorter list of options. But we've got lots of choices. We have some of this, some of that, some of the other. In our case, we're very specifically trying to deny something. And we've already identified what it should be. So what do we deny here? Deny what kind of protocol? What type of traffic? And I think some of you are very wise, but maybe because you've been on my webinars before or known each other. Keep speaking up, keep responding, even if it's just in the question thing, because I'm not hearing voices. So if you're talking to mute. And this thing keeps moving. If you don't respond, I will stare at you all day long. Yeah, absolutely right, Steve. We got to deny TCP. We even said it in our questions up there. Yeah, TCP port 23, so TCP. So let's get real specific. And in general, one of the best practices with access control lists is try to do your most specific stuff first in your access control list, because they work in a way that says start at the first rule or the first permit or the first deny. And if you get a match, if you match there, you say, okay, you're permitted or you're denied, and you sort of drop out of the ACL. But if you don't match, then you go to the next rule and the next rule and the next rule. Well, if you start with the most specific stuff, then you'll drop out of your ACL and have permitted or denied as you saw fit earlier and require less processing from the router or the switch or the firewall or whatever the thing is that has the access control list or other lists that controls traffic like an ACL. So we're going to be more specific. We're going to be denying TCP. And the next question mark tells me, okay, give me a source address. So we got three options. We can specify one very specific address. We can say any host in the universe, or we could say a single source host. Well, a single source host is not going to get it, because then we'd have to do a single IP for every one of the PCs on those VLANs, plus every IP on the internet. And that's never going to work. And yeah, so Dylan says any, and Jeremy's like, well, we want to block all the traffic, so let's just use any. Well, that makes sense. But wait a minute. Any also includes all the PCs in the engineering VLAN. Would that be a problem? Would we break traffic from one of these PCs to another device in this VLAN if up on this router we pinned up an ACL that denied from any in the universe? Does anybody have a thought on that? Steve said a little bit, yeah. Yeah, I think so. It's the kind of thing where you should go, hey, wait a minute. I thought I had this figured out, but maybe I don't. So you have to ask yourself, traffic coming from the engineering VLAN headed to something in the engineering VLAN, destination port TCP 23, telnet, would it necessarily go to the router and cross an ACL and then go back to a device in the same local area network in the same broadcast domain? Would the ACL ever affect traffic sourced from this VLAN and destined to this VLAN? Yeah, Jeremy's right. Now he's speaking more, concretely. Yeah, no, it would not. And you're absolutely right, it wouldn't. Because we know the way that ARP works, the way our layer 2 broadcast domain works, is something inside of this VLAN with an IP of 172.16 is going to try to talk to something else in this VLAN of an IP address of 172.16. It's going to say, hey, I need your physical address. I need a MAC address. Because the rules say I got IP, I got to figure out a MAC. ARP is the way we figure out MAC. That's what we talked about in our last two sessions, if I'm not mistaken. It's going to ask, hey, who's got this IP address? Some device on this local area network is going to answer, say, hey, that's me. Here's my MAC address. And the router's never going to come into play because the router is not going to have that IP. The router's going to have some other IP. So absolutely right. It would not. So it looks like any actually does accomplish what we want, because by default, the engineering VLAN as a possible source, remember we're talking about the source part of this ACL, this deny rule, it never really comes into play. It never gets affected by it. So any does work, and it works well. I could have just said, yep, any, we're great, but I wanted to make sure we're thinking about that. And that's a big part of what like I was saying earlier, I didn't get that too early on, but you want to try to think of every scenario when you're creating rules like these so that you don't have to come back later and go, oh, gee, there was this thing I didn't think of, and now I got to change and add this permit. Well, let's slide a permit in here because we didn't think of that. If we're lucky and we're smart, we can strategically build and place this in a way that doesn't require us to come back to it. So that's why I'm intentionally trying to make us thoughtful about it. So, yep, deny TCP, source address, any source IP address in the universe. Question mark now says, okay, what do you want for a destination? Is it to any destination? Only certain things? A single host? A range of port numbers? So we're very much got a lot of options here. So what do we want to do? Yeah, Dylan's already jumping ahead thinking this through, and I think it's very wise. Yeah, for destination, we want to focus specifically on the 172.16.0.0/24 network. Any wouldn't work for that. That covers way too much stuff and could most definitely create a problem for us. So I think we try that. 172.16.0.0, that's the network address. That's sort of just intended to represent everything in that subnet or that network. And if I use the questionnaire, it says, hey, give me some wildcard bits. Now, if everyone recalls before, I don't have it in front of me, when we created IP addresses for interfaces on router 0, we did have to specify a subnet mask. On this screen, it's represented with that CIDR notation, that's /24. But when we typed it into our sub interfaces, our .10, our .172, .192 interfaces, we actually had to type it out, 255.255.255.0. Well, with ACLs and some other functions, especially routing-specific functions, you use what's called a wildcard mask, which is essentially like an inverted subnet mask. So as Dylan had pointed out in his response a second ago, instead of typing 255 and actually this router's pretty smart. If I type it this way, it's probably going to know what I meant and fix it. But instead of typing 255.255.255.0, which really just represents, if this were binary notation, 8 ones, 8 more ones, 8 more ones, and 8 zeros. I'm not going to go into how I knew that in this class, but it's something you absolutely should know if you plan on working in IP for a living. We're going to do the opposite. We mean the whole /24, but we're going to type it 0.0.0.255. So what we're saying is 172.16.0.0 network, that's about 200, well, that is 256 addresses big, including the network address and the broadcast address, the .0 and the .255. So coming from anywhere, headed specifically to this destination, if the destination IP address of that packet is here, it could be considered interesting traffic. Let's use our context-sensitive help again and see what's offered. We can hit enter here if we want, but then we probably being too broad with what we're blocking. We need to be more specific, and Dylan already kind of is ahead of the game. Yeah, we want to match only on a specific port number. And when we say port number in this section, we're specifically talking about destination because we're applying it right after the destination IP address. So equals EQ, I don't know how to type there, and we can put an actual number. And as somebody mentioned earlier, a couple of you mentioned earlier, TCP port 23 is what's used for telnet. That's destination port 23. But you can also just use the keyword telnet. And in fact, I think if I put a 23, it's going to change it in the configuration to the word telnet, which is perfectly fine, does the exact same thing. So I'm going to, just for grins, I'm going to type 23 and see if it changes it on us. So after that, the only other thing left is established keyword, and we're not going to use that here because its use case, it doesn't apply so much to what we're trying to do here. So we're going to leave that one alone. And we do have the option of just pressing carriage return or enter. That's what CR means in the brackets. So there we go. We've created a rule that says, hey, no traffic can get through here. And in fact, if I were to type do show IP access lists, it would probably summarize what we've built. There's the ACL we built last time we met for this access list was specifically for the network address translation if you were heading from a private address to the public internet. But here's our new ACL that we just started building. Extended IP access lists, engineering security. Line number 10 says deny any TCP traffic from any source headed to this specific network destination, assuming it's 23. And you'll notice it did change the 23 to telnet. So let's see, I'll make sure you didn't have any questions for me. Okay. So we're saying deny that traffic. Are we done? Is our ACL built? We're all happy? I mean, we've got the one deny that we need to have in place. Or maybe we're ready to rock, ready to apply that ACL somewhere. Yeah, Jeremy's like, yeah, we got to put on an interface, though. It doesn't do anything unless you apply it to an interface. Steve aptly pointed out that the last time we talked about it, when we were building this ACL, there is an implicit deny all at the end. So the way all access lists are written in Cisco universe and in much of the network universe, if you don't match this rule, or this rule, there's an implicit, okay, then you're denied. We're not just going to let you slide by. We're going to assume you meant to deny. And actually, the best practice there is to go ahead and make it an explicit deny all. I don't know why we didn't do that here. We probably should have. But in this case, it's the same problem. We're saying, hey, deny anything headed from anywhere to here. That's telnet. And then the implicit deny all means everything else gets denied too. So if we apply this access list as it is right now to a specific interface, it's going to deny all traffic. Not just what we specified here, but everything else based on that deny all. So it says we need to permit everything else that we want to allow. That's a good point, Steve. So how do we do that? How do we permit everything else? Yeah, Jeremy's like, well, we need a catch-all, like permit any. And that's exactly right. We don't have to try and craft a permit statement that says this address and this address and this network and this network and this. We really couldn't do that, practically speaking. And what's nice is because we put our more specific first in the ACL, as long as we just say everything else is allowed, then we got it covered. And the way we do the everything else is allowed, we use the permit keyword. And we just say, hey, instead of being real specific on port numbers with TCP or UDP or any of those other fun things, let's just be real generic and say, hey, any IP traffic from any host, see it says source host, so from any host because it's source, question mark again, to any host. And you can just stop there. There are some other things we can do, but we'll leave those alone because we're not worried about any kind of type of service. We're just saying permit everything, any direction it's going, I should say any source to any destination, just let it go by. Now, again, I'm going to use my up arrow to get to my prior commands, and I do a show IP access list. Access lists, again, we talked about a second ago, they are always processed and acted upon in the order in which the rules are written. So our rules were written first, the more specific. If it's telnet, headed from here to here, deny it, everything else gets allowed. And that's how you do the everything else piece of it. And in theory, there's actually still a deny all after that. There's actually still one there. It's just never going to, no traffic is ever going to hit that deny all because of our permit IP, excuse me, any. So the way it's written is first, check it here. Are you going from here to here equal that port number, destination port number? Or if you are, you get denied. If you're not, go to the next rule. Next rule says, well, are you coming from any IP address to any IP address at all? Well, if you are, you're permitted. There's your catch-all. There's your everything else rule, very simply written. And it's the nature of the way access lists are processed that makes it behave that way, that we don't have to try and figure out all the possible sources and destinations in the universe. All right. So we've got what I consider a complete access list that accomplishes the goal based on the instructions they gave us, which is awesome. So how do we apply it? Earlier, Jeremy mentioned, well, we need to apply it to an interface. And this is where it gets really interesting. So depending on how you look at it, you could put it up any of a bunch of places. So recall that our router has essentially, let's do it this way. I'm going to end out of my global configuration mode. I want to type write mem so that I can not lose my configuration if we get reloaded. And I'm going to do a show IP interface brief. And what we notice about our router is we have two physical interfaces, one fast Ethernet 0/0 and one fast Ethernet 0/1. Fast Ethernet meaning that it's 100 megabit per second capable in both directions. And it's got some numbers, module number, port number, something to that effect. But we've got 1, 2, 3, 4 IP interfaces because we have these sub interfaces in play for our router on our stick configuration that I talked about earlier, that we talked about it, and then we went through in detail in the prior labs. So we've essentially got 4 places, maybe 5 if you count the physical interface fast Ethernet 0/0. But we've got multiple places where we could assign this ACL and say, hey, stand guard at the gate and deny the traffic we said to deny and permit the traffic we said to permit. So the question is, where should we apply it? And how do we know where should we apply it? And is there more than one place we could apply it? Anybody have a thought? Dylan likes using our interface 0/0.172, our subint, outbound. And Steve said the same thing. Let's use this interface. So why are we choosing that interface? As I take a sip of my water so my throat doesn't become dry from talking. Can't just spit it out. You got to give me a reason why. Why are we using that interface? Let's move router 0 out of the way for a second. Best practice. It's closest to the subnet. I think that makes sense. Best practice, extended ACL. Let's see here. I'm just picking something. I'm totally at random. And this is not the most official way to do it, but actually source or destination. Aha. So one of the places you get is, ACL uses for your researchers closer to the destination. More efficient, don't need to apply it to every interface, said Steve. Dylan, like, yeah, it's closest to the subnet. It's kind of a common sense thing, probably, from your folks' perspective, which I think is right. So it's considered best practice to place an ACL as close to the source as possible being filtered, but yeah, standard ACL goes closest to destination, extended ACL closest to source. And it has to do with the way it's processed and how to be most efficient about it. So this is a little trickier. So to me, there's not a super pat answer. You can either apply it to multiple interfaces. You can apply it to the interface where traffic would be coming from here, and here, and here. These are kind of the 3 non-engineering VLAN places it could come from, right? Or you could apply it on the one closest facing to here. That's not so cut and dry because, if I'm applying it to multiple places, am I making the router work harder than it necessarily needs to? That's a good question. So if we apply it to all of the interfaces inbound, which would make it closest to the source as possible. So what's the best interface that's closest to the internet as a source? Well, it's fast Ethernet 0/1. That's an easy one, right? If I hover over router 0, yeah, that's the internet interface, right? What's the closest interface to go to? IP interface, mind you. If it were coming from here, well, it's going to be that fast Ethernet 0/0.192. So I put it on multiple interfaces. Now I'm closer to the source, which is considered best practice. But then I got to put it on multiple interfaces. I don't know. I don't know if I like that. It doesn't seem as efficient. It doesn't seem like, well, see, now every time I tweak that ACL, maybe I add a new rule, I have a new thing I have to account for. Now I'm affecting 3 interfaces instead of 1. I don't know if I like that. But if we go, let's put it on closer to the destination, let's buck that best practice and put it closer to the destination. Well, which would obviously be what you guys mentioned, 0/0.172. Well, then that means the router has to route the packet from incoming or ingress interface to egress interface first, and then process the ACL. So yeah, you have it applied to fewer interfaces, but then you do force the router to, in a sense, do the routing, take care of the routing functionality, and then process the ACL. So that's kind of the primary reason is let's not force the router or routers to do the routing part, which could end up being for absolutely nothing, which costs you CPU, whether it's on a specific route processor card, or if it's the device as a whole, if it's a smaller device like we have our Cisco 1841 example here. We're chewing up routing resources unnecessarily for a packet that should have never been routed because it should have never been allowed. So I think in this case, let's follow best practice and let's go ahead and go as close to source as possible, and let's stick this ACL on the interfaces closest to the sources. It's just that we have more than one source. There are other ways to handle this problem. Saying, hey, let's pick a router on a stick and make an ACL that does this real specific to this VLAN is probably not the best build architecturally speaking. If you were building a network from scratch in an enterprise environment, this isn't exactly the way you would attack it. But for our example, it's a really good way to get us to the place where we're sort of doing the intellectual exercise. We're thinking about, gee, where would I apply this? What does it affect? How could it be impactful to the router? How could it be impactful to the traffic? So let's tackle it that way. Let's go back to router 0. I'm already on top. Oh, sorry. There we go. So let's go ahead and apply it to here, here, and here. That's the 3 possible source interfaces. And then real quick question for you. Should we apply it to 0/0 as well? Maybe just to be on the safe side, or is it necessary, or is it impossible for traffic to be coming from that place? Steve's like, I think so. I suspect so. Jeremy doesn't think it's necessary. Why? Why do you not think it's necessary? Oh, good. We've got even more attendees now that I look at the list. That's wonderful. Yeah, unassigned IP is kind of the hint there. Yeah. So essentially, there's really not a way for traffic with an IP address in our current build to even get through that interface. It's essentially untagged traffic. So the only traffic that's really ever happening, it's really not traffic coming from the interface, as Jeremy put it. The only traffic that's really coming from or going across that interface, that physical interface 0/0, is traffic without an IP. It's control plane traffic, or traffic that is specific to routers and switches talking to each other, but not for the data plane, not for the traffic going from a source to a destination, like a PC to a client or to a server or something like that. Steve raises the point, well, but maybe it will later. Should we do it in case it's an active interface later? That's actually not a bad idea. It's not a terrible idea. In general, I would say most people wouldn't. But it's actually a really thoughtful idea to mention that. So yeah, you never know. I think we're going to leave it off for now, but you're absolutely right. You never know if it could be later. Maybe at some point we use that untagged VLAN, that untagged area of traffic, that untagged broadcast domain for something. So something to consider. So let's go back to global configuration mode. We're going to go to interface 0/0.10. because that was one of our possible sources. We're trying to get as close to the source as possible. And the question is, how do we stick this access control list, this ACL, on that interface? What do we got to do? This has been a very knowledgeable audience so far. Yep, IP is the way we start. This is an IP-like command. And when we do IP, if you see, the very first thing is specify access control. Jeremy guessed IP access list, but as you can see from content sensitive help, for whatever reason, Cisco used access group. I'm confident it was because it didn't want to have it. Yeah, you were very close. I'm confident Cisco did that so that it couldn't possibly be mixed up with the access list. So yeah, Dylan's on top of it. So we'll say IP access group. And it says, okay, what's the number of the standard or extended ACL you want to use, or what's the name of it? Well, we named it engineering security, EngSec, so let's specify that. It is case sensitive, so pay attention to that. I like to use the all caps in this for this use case. I probably mentioned it last time with the other ACL because it lets it stand out and show that it's more of a user-defined field or user-defined information as opposed to the actual control words or keywords of the Cisco configuration. And then you got a choice. Is it for inbound or outbound packets? Now, earlier we were saying, let's apply this outbound on the .172 interface. Should it be outbound? I've already got one guess on that, but I'm curious if anybody else. Yeah, we're saying inbound. Why is it inbound? Why wouldn't it be outbound? Yeah, in a sense, it is. It's receiving the data, not sending the data. So and it's a little trickier because these are virtual interfaces. You can't see it. You can't see and touch it very much so. Yeah, blocking what comes in from the other VLANs and internet, yeah. So we're saying, hey, here, we're applying it here. If it's coming into our fast ETH 0/0.10, well, then let's block it. If it's going out, we're not paying so much attention to because it has nothing to do with what our rule was about and how it was to be applied. So that's exactly right. Let's say inbound traffic. Boom, we're good to go. Now we need to specify our .192 interface. And I'm just going to use my up arrow because it's faster and I'm lazy. And I type the same command. Same thing, it's inbound. And the only other thing I think we concluded we would do is anything coming from the internet. So same thing, if it's coming into our router from the internet, let's apply that ACL. Sweet. All right, cool. So let's see. Steve offered up an interesting question. Well, wouldn't we need to apply it to outbound to the 0/0.172 as well? Or do I remember wrong that ACLs don't apply to traffic sourced from the device they're configured on? Yeah, that's exactly right. That's a very good question. And Jeremy is suggesting, no, you really don't need to, that it's going to cover it in terms of the way we built ACL. But the use case Steve is pointing out is, well, what if you're coming directly from the router? Jeremy's like, no, we got it covered. All the other interfaces covered. But Steve's right. Wait a minute. What if we're coming directly from the router? Oh, shoot. I can tell you with a great deal of confidence that, yeah, it's an interesting use case. So let me pose the question back to you, Steve. If we were coming directly from the router, trying to telnet, as an example, telnet to 172.16.0.2, which automatically implies port 20, destination port 23, so we don't need to say 23, although we certainly can here. If we're doing that, what's the source IP address of that request as it's generated from that router? Because that really helps to answer the question you posed. Anybody have a guess? What would the source IP address be? Because I'm not specifying it, I'm just specifying destination. Steve's like, oh wait, maybe there is no source IP because we don't have a management address on the router. Actually, no, it's not the case. Router has its own special set of rules in general, if not globally across all routers everywhere in the universe. I have to research that one. But there is a special rule. Yeah, Dylan's like, well, wouldn't it match the subnet? That's exactly right. So go back and look. Show IP interface brief. We've got IP addresses, and what routers do when we don't tell it specifically use this source IP, a router will always attempt to use the IP address on the exit interface. So as we say head towards 172.16.0.2, it's going to know when we look in the routing table, show IP route. Oh, to get to the 172.16 network, I know that's directly connected to me. I would send traffic out fast ETH 0/0.172. So that means it's going to assign its IP address of 172.16.0.1 to the source. That would be the source, and then whatever destination we specified. So question one that Steve had brought up is, well, if it's coming from the router directly, does it even hit that ACL at all, even if we apply it, to that interface? You know what? I don't remember. That's a fantastic question, and I should know the answer to it, but I bet we can find out. But two, even if it does, do we necessarily want to block that traffic? I mean, if you think about it, the way our rules were written, our assignment was written, it says, let's see, in advance of lecture requests, yeah, that no telnet requests can reach any equipment in the engineering VLAN from outside that space. Well, isn't 172.16.0.1 technically in that space? I mean, it is, right? It's technically the engineering space. Turns out this router participates in multiple different spaces. Yeah. So technically, to meet the criteria we got from the ticket, we should allow that. But Jeremy's like, I don't think it's going to hit the ACL no matter what. So let's do this. Because we wrote our ACL show IP access lists to say, hey, any source that's headed to 172.16 space, deny it. And we knew that if it came from anything down here, it wouldn't even get denied. It would never even try to hit that ACL. But coming from here, we didn't think about that one IP that lives in that space that hangs out up here. Let's see what happens if we apply. This is mostly for grins. Interface fast 00.172 IP access group INSEC. Now we do outbound, as you folks mentioned. Hey, do we want to try it outbound? Let's stick it on there. And then let's see what happens. If I telnet to 172.16.0, oh, you can't type, 16.0.2 from the router, it should, if the theory holds, assign .1 in the same subnet as the source IP. And, all right, it says connection refused by remote host. That suggests that whoever holds 2, which would be this PC, PC5, is simply not listening on, where do we have it? I can't control it here, can I? It's simply not listening on port 23. It's not hanging out waiting for someone to try to telnet to it. That's not what it does. It was like, no, I don't think so. Thanks, but no thanks. So, in theory, if we got denied by this rule, it would attempt to log that. It would show a match. We're going to have to test that theory. I think it doesn't even hit the ACL. I think it completely bypasses it because, in a sense, you would almost treat it as if that IP interface sort of, or that IP for that interface sort of lives past the ACL, because there is an order of things, an order of operations. Does it ACL first? Does it route first? What does it do? I don't have those memorized anymore, but that totally matters. And you guys point out a really good point. So thank you for bringing that up. But let's test it. Let's do this. Let's try to telnet from outside and see if we in fact get denied, what it looks like when we get denied, and does it log as a hit on this ACL? Because I know when we hit the internet before and it matched to do the NAT, I believe it logged and said, hey, I had 2 matches or 5 matches or whatever. So let's give that a shot. Let's try to come from outside of that VLAN. And we'll go to our command prompt. And we're going to say, hey, telnet to 172.16.0.2. Still a good example. It's as good as anything else, right? And see what happens. I'm trying to get there. 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 It just timed out. So did it hit the ACL? I don't know. Let's see. Hey, look at that. It tried, and it kept getting caught in the deny. It never made it to PC5, where PC5 was like, hey, dude, I'm not listening on that port. You are denied. Get lost. I got nothing to say to you. Like it did to us. Where was it? It's right in front of my face, right? There it is. Connection refused by remote host. So the ACL works. The ACL blocks in the appropriate way. It happened to come traffic that was coming from 10.0.0.0 space. But even when we've applied it to show run, let me find it, make sure I'm not crazy. We did, in fact, apply it outbound. Yeah, even when we applied it outbound here, nah, it doesn't. Not coming from the router, it doesn't. So for grins, let's test that theory. Telnet 172.16.0.2, still trying to hit PC5, and he's like, no, not going to do it. So like we said earlier when we were talking about it, traffic isn't even going to go up to the router to even attempt to hit an ACL to come back down to its own same subnet. In the rules of IP and MAC and ARP, No, I just ask who's got it. He says he's got it. I reply back. We talk. The traffic never, if we were to watch traffic as it flowed, it doesn't even, generally speaking, unless it's broadcast traffic, it's not even going to go up here. It becomes unicast traffic after the ARP process takes place, and it just goes back and forth between these two in this example. So, good point. It doesn't actually hit that ACL coming from the router specifically. But let me see if it will let me change this. This is packet tracer, so it may not let me, but if I can change the source IP, that might be helpful. So I'm going to hit enter and see if I can get some extended commands. I'm trying to get to 172.16.0.2. Again, I'm coming from the router. And no, I can't do it. So there are some extended commands you can use in a full-fledged version of this where you say, hey, come from a different IP. I can pick any IP address I want, show IP interface brief, and say, hey, come from this one or this one. If I were able to do that, it would actually hit that ACL because in a sense it has to cross the router, so to speak, to be routed. And when that happens, it would be forced to go through the ACL. It would have a source address that fits the any source of our rule. Where's our rule? I know it's here. You can't hide from me. It would have any source address. It would get processed trying to get this direction, and it would get denied. So let's see here. Yeah, and we don't have any matches on our permit any. So when we tried to get from PC4 to PC5, again, we never even hit the ACL at all. So I think we have applied our ACL in the three interfaces where it needs to be, here, here, and here. I agree at this moment we don't need it here, although Steve pointed out aptly that, hey, maybe you need it later. I'd say we apply it later if we think we need it. I'm okay with leaving it for now. I wouldn't, generally speaking, you wouldn't consider that a security flaw or security hole, generally speaking, because this is all internal space anyway. It's what we consider trusted space from a firewall perspective or a DMZ perspective. So I think we've met the criteria of this ticket. It took us about an hour to do it, talking our way through it slowly. So that having been said, we close the router. We've got our ACL. Why don't we open the ticket or open the, I'm not going to save this because there's no need. I have the base file already saved. So let's go to the next thing on our list. Same environment. Everything looks the same, except you'll notice they've got a server in the engineering VLAN. Hey, what's going on here? So let's talk through that real quick. And hopefully we complete this in the next hour because I didn't want to run longer than 2 hours, and I believe we will. Pretty sure we will. So engineering has added a server to their local area network which will perform FTP and syslog functions for the network devices. The new server has been connected to the engineering LAN on fast 0/5 of the engineering switch. And if I hover over these interfaces, you'll see fast 0/5 lights up on engineering switch. Cool. And if I hover over the switch itself, you'll see all the interfaces 1, 2, 3, 4, and 5 are up. The rest are down. Excuse me. And we'll notice fast Ethernet 0/4, which is our uplink, is not have a single specific VLAN set to it because it's known as a trunk. We won't go into that. We talked about that when we configured those in the very first lab. So in order to take advantage of the FTP and syslog functionality of the server, it has been determined that all network devices require management IPs, which is something I think Steve mentioned earlier. Oh, no management address. Yeah, there's kind of technically no management address on the router. There's definitely no addresses on the switches. You don't see a single IP when I hover over them at all. So let's see. For management reachability, use the last available. This gets really cute, so I apologize in advance. You have to read this 3 times if you get the lab in your own hands. For management reachability, use the last available IP address in each VLAN for the LAN switches. So for accounting, we'll use the last available address in this subnet here. For engineering, we'll use for that switch, we'll use the last available address, and for IT switch, we'll use the last available address in that subnet. Use the next to last available IP address in VLAN 172 for the AG switch. So we're saying, hey, let's have the AG switch from a layer 3 perspective, from a management perspective. Let's have it live in the engineering subnet. That's just what we decided. You could have picked any subnet you wanted because all 3 VLANs, these local area networks, come through here. So you could have picked any. We just happened to pick 172. We thought it would be fun. And let's see. let's use the second to next to last available IP address for the engineering server because it needs an IP address as well. So unlike the PCs, which we had them acquire their IP addresses dynamically through DHCP, we're going to statically set it because it's a server. So we're going to pick one, and we have picked one, the second to next to last available IP address. And we have to pay attention to any statics we apply. We've got to pull them out of our DHCP pool so they never get issued by the router to any other host that jumps on the network. And we should configure all switches and routers to send their logging to the syslog server located in the engineering LAN. So this is some of the network stuff that was getting put together that we had those ACLs, that ACL built for. Now, what I bet you in my saved version of this, I have that ACL applied not to the interface or the interfaces that we chose. Let me have a quick peek at that. Show running configuration says that, yep, it's only applied IP access group engineering security outbound on .172. So it's literally the opposite of what we did on the other lab. So for grins, I'm going to fix that really fast. If I can type config T, interface fast Ethernet 0/0.172, no IP access group eng. It looks like I use an underscore on this version. Sec out. Interface fast 0/0.10. You're going to go here. I use Control A to bring my cursor all the way back to the beginning of the line. Control E takes you to the end. Control W deletes the last word. And let's do the same for .192, using lots of up arrow to make it go faster. And let's do for the internet interface. Now it's like it was when we left that lab a little while ago. So my apologies for that. I was sloppy when I put it together earlier. Okay, so let's see here. You notice it didn't pick or mention a management IP, Steve, for the router. And the reason is we've got lots of IPs, and if we're only using the local area networks as the management to grab a management address, as opposed to creating a separate broadcast domain and separate IP area for management only, which is something that is not it's often done, then Router Zero's already got IPs in all those VLANs. So we'll just say 172.16.0.1, for example, could be our IP address. In fact, that's what we'll say as management because we did the same for AgSwitch. We said you live in the engineering subnet. So let's just do that. So where should we start? I think maybe we'll minimize our router. And let's go ahead and pin up management addresses on these three switches. And if anybody objects or wants to do something different, you just speak up in the question or unmute yourself. So how do I assign an IP address to the switch? I'm in the accounting switch. I say enable to go into privilege executive mode, and I need to configure something. So we got to configure terminal. And I got to figure out how to put an address somewhere. Steve suggested, do we have to designate a management VLAN? Well, in a sense, we did. Our instructions designated it for us when it says just use VLAN 172 for management IPs. Or in the case, actually, I'm sorry, it specifically said use the last available IP address in each VLAN for the LAN switches. So essentially, just use the LAN segments. Don't have to make a separate management VLAN. It's very often done. It's good practice to do so. But the assignment hasn't required that of us. So we're just going to grab, again, next to last available IP address to assign for management. You could do it either way. So it's a good point. But we're going to use the VLANs that they told us to use, which are the LAN segments. It's VLAN 192 for this guy, VLAN 172, VLAN 10 for that one, VLAN 172 for aggregation per the instructions, and it did not ask us to do one for router 0. So there we go. So let's see, where was I? Okay, accounting. Accounting switch is supposed to live in the 192.168.0.0 subnet. So what VLAN is that? What VLAN did we pick for that when we built this thing? Anybody remember? Accounting. 192 is correct, Steve. So let's do let's see. Do show IP interface brief and exclude all unassigned interfaces. We have no IPs on here anywhere. How about we do this? Show run. See, we got lots of VLAN 192 on here, which is cool. That's what we expected, right? And that's about it. And if we have this interface VLAN 1, so that's something that could be a routed or an IP interface, but we're not supposed to use VLAN 1. Our instructions said not to. So we need to create our own big T interface VLAN 192. So it's not the same as VLAN 192. This is very often confuses people. VLAN 192 and all of our virtual local area networks are layer 2 constructs. They're layer 2 broadcast domains. The switch does layer 2 exclusively. You saw no IP addresses on there when we said show me my IPs. So we're now adding a layer 3 functionality to this to say, hey, give me an interface with an IP. And because we're supposed to have it live in VLAN 192, we're calling it interface VLAN 192, or more specifically, more correctly, IP interface VLAN 192. So, boom. As soon as we create it, it says, oh, okay, well, that virtual interface, that's not a physical one that you can touch like Fast Ethernet 0/1 or 2 or 3. Well, it's up. And the reason it's up is because there are interfaces up on this device that live in VLAN 192. If all of these interfaces were down, Fast Ethernet 1, 2, 3, everything that's up, if they were all down, the interface VLAN 192 would actually also be down as well. But since it's got interfaces alive, it says, okay, I guess this IP interface gets to be alive. So no surprise, just like our interfaces we did on router 0, .10, .172, .192, and even the physical interface Fast Ethernet 0/1, we said IP address blah. We're just going to do the same thing here for the accounting switch. So if you look, Constant System Help says you want to do some interface protocol commands, do it. IP, surprise, surprise, address. All right, so what IP, according to our instructions, needs to go on interface VLAN 192 on the accounting switch? 192.168.0.254 with a subnet mask of 255.255.255.0 according to Steve, according to Jeremy. I completely agree with you. But Scott says no. It's 253. This is a good one. Why? Why is there a debate there? Why can't it be 254 or why should it be 253? What's your thoughts? Jeremy's like, Scott, you're right. Why is that? Yeah. We got the broadcast address, which is what? Who types the fastest? This is where we're all learning to type number pad. .255, Steve's smart. He shorthanded it. Yeah, 255 in our particular sized subnet, what we call /24, which is 255.255.255.0. 255 is already reserved. It is not available to be applied to a host anywhere. You're not allowed to put it there. And most hosts, if you tried to, it would say, hey, I can't use that. That's the broadcast address, dummy. So we can't use that. So the instructions say for management reachability, use the last available IP address in each VLAN for the LAN switches, and then the next to last available IP address for aggregation. So, based on those instructions, I'll read it again. Use the last available address in each VLAN for the LAN switches, accounting as one of the LAN switches. Which is it? 254 or 253? I can sense the smoke coming out of some of your ears. And Jeremy's like, 254. Steve's like, 254 is the last available. What do you think, Scott? You want to change your answer? Or you want to stick with 253? He's thinking hard. I'm just waiting it out. Torturing poor Scott. He's like, dude, take the spotlight off me. I hate you. Scott and I have known each other for a number of years, so I'm pretty sure he won't hit me the next time I see him. Yeah, the answer is definitely, second. 253 is second to last, as Scott mentioned. And in this case, for the LAN switches, like accounting, we're just supposed to use the last available. Well, 255 is not available. The last available is 254. So Steve was like, well, 253 would be right for the ag switch, and you're absolutely right. It's the next to last available. My wording was really poor there, so it's nobody's fault but my own. But I kind of like that I did it that way because you have to think about it. And you absolutely, and it's easy to second guess yourself, as Jeremy pointed out, because this stuff, it's a different level of thinking. Nobody here is too dumb for it. We're all plenty. Let me tell you, if I can do this job, anybody can do this job. We're all plenty smart enough for it, but you have to think your way through it, because it's going to be. And he said, "It's still." Steve was like, "Yeah, but it's still not as tricky or confusing as a Cisco exam question." Yeah, you're kind of probably right about that, but we will say that it's strictly a matter of opinion. We're certainly not in a place. I'm not in a place to endorse or decry anything about anybody's exams for certain. In any case, the IP address we want to use here is 192.168.0.254, subnet mask of 255.255.255.0. Now we have an IP address on the switch, which we did not have before, that gives us a way to communicate with the switch remotely. It's that management IP. So we can control and configure it remotely. Every time we click on these, it's as if we're plugged into the console port. It's as if we're directly plugged into it. We're not even using IP per se as a protocol to communicate with it. We're plugged in directly to it. Now we have a way to get to it remotely, which is cool. So let's just test that real quick, see if it works. So if I'm router, and say I wanted to telnet to 192.168.0.254, which is what we just assigned to the accounting switch. Okay, it tried and it actually got closed. It opened though. So we did successfully telnet to it, but something happened. It worked and then it stopped working almost immediately. We'll have to figure out why that was, but maybe we figured out a little bit later. So, all right, let's see. Cool. We have to allow it in the switch if I remember correctly. I think in a way that might be a true statement, but we're going to hold off for now. There's something we do need to do, but let's talk about it. Let's talk about it here. We'll come out of global configuration mode. And in our router, when we wanted to know, how do I get to networks, all the networks in the universe, we would say show IP route. Okay. Here, our routing table, for lack of a better way of saying it, is essentially empty. It really only knows about the one network to which it's attached, and it doesn't even tell us that per se. Because this is a layer 2 switch, it's not a router. But there's one routing type of functionality that has to happen. In fact, it exists on all of the hosts, not just switches and routers. So the question is, if something or someone is trying to get to accounting to manage it remotely, trying to telnet to that IP, traffic comes from somewhere, from some IP address, and goes to somewhere. But it has to be able to reply back. For telnet or any other protocol to work correctly, it has to be able to reply back. Well, if you ask accounting, how do you reply back to some IP address somewhere? It doesn't know. It doesn't have the ability to. So if we look at our PCs, here's an example, and I go to the configuration, fast Ethernet 0 on this PC, got that dynamic address with appropriate subnet mask, but it also got another important piece of information. Got a gateway IP. It has a default gateway. Well, we haven't assigned a default gateway for accounting. You can see it right here. Hey, default gateway is not set. I don't know how to get anywhere. I don't know the MAC address of the interface on some device somewhere, probably a router, that gets me, is my gateway to the rest of the world. And I need to know that if I'm going to communicate in both directions. Yeah, people can get to me, but I can't answer them. I don't know how to get back to their IP address. So we need to configure the default gateway. Well, what is the default gateway for this IP address? What's the default gateway for everything that lives in this subnet? Put this on top so it stops disappearing. Yeah, 192.168.0.1. It's the IP on the router specifically. And Dylan and Jeremy were both like, hey, dude, the syntax is easy. You just go into global configuration mode and say IP default. I'm trying to use my tab key. Gateway. And you just specify the IP address of the default gateway, which is 192.168.0.1. There we go. Now if I say show IP route, it does have a default gateway. And more correctly, because this is not a router, this is not even a layer 3 switch, it's simply a layer 2 switch with an IP address on it. If I say show IP default gateway, is that right? Default gateway? Now I'm going to drive myself crazy trying to figure that out. Okay, all I can do is show IP route. That's okay. Point is, now we know our default gateway. This is definitely very limited. My apologies. So in theory, traffic should be able to go back and forth successfully. Let me close that. Let's try to open that telnet session again. No, still won't. Yep, there's something else happening. And in fact, I think it was Steve. Yeah, who said it first? I want to give credit where it's due. It was Jeremy. We have to allow it in the switch if I remember correctly. And it's Jeremy again. Hey, dude, you got to say allow telnet specifically. You're absolutely right. You're absolutely right. So, and I guess I was ducking this a little because I was trying to avoid the concept a little bit of the VTY lines, but let's not duck it. This is part of the configuration. We should just do it and do it right. Okay. So if I do a show run or do show run, since I'm in global configuration, I'm going to go all the way to the end. There's this section that says, hey, line VTY 0 through 4, and there's a login command. Well, we're missing some stuff. So I'm going to configure that section of the router. Line virtual terminal or virtual teletype 0/4 or 0 through 4, so 5 possible lines to remotely control this device. We've got some options here. One of them is the very last one, transport. So let's define some transport protocols. Define which protocols we use when connecting to the terminal server. So anything incoming, we're not worried about outgoing. So for anything incoming, transport input, we got to say allow stuff. Allow SSH, allow nothing ever, allow telnet. So if we see telnet here, hit return, it's probably going to be allowed. I suspect it's going to look for a password, but let's find out. Put my router on top again. Put this in the corner here so we can see everything. I'm watching my clock too, making sure we're good. Let's try to telnet to it one more time. Yep, it still gets closed, and there is a reason for it. I don't remember what it is, but we're communicating successfully in telnet, which is going to be enough for now. I think it will meet the conditions of the lab. I should have probably sorted that out earlier. Yeah, it's got login in there. Dylan pointed out. It's got login in there. So in theory, you could try to set password. We'll give it a shot real quick, and then I'm going to stop monkeying with it. I'm going to call password Cisco because why not, right? And I think that, yeah, absolutely. That was what it was. And apparently, there we go. Apparently I can't type, or I had the caps lock key. So yeah, we set the password Cisco inside the VTY configuration section, mind you, not globally. That's a different password. And by doing so, we're actually working from router 0, but we're actually remotely controlling the accounting switch. And then when I try to go to global enable, it says, no, you didn't have an enable password set. And that's another feature. We're going to leave that alone for now. And then I just exit and I'm back. I'm actually just in my router natively. No more remote configuration of account. So cool. We've got we proved it worked, that we have an IP address on the accounting switch, which is one of the LAN switches, which means the last available IP, our .254. And we even set a password for logging in and made sure telnet was allowed. So I think we should just do the same for the other 2 LAN switches. Let's just do that real quick. I'm going to close accounting. I'm going to grab, we're going to be short on time. Oh dear, what have I done? Close that one, close that one, close that one. I'm making a mess of things here. Please bear with me. Engineering, there you are. Don't hide from me. Okay, so let's do the same thing. So engineering lives in what subnet? Oh, done it again. I'm watching for your responses here. What subnet does engineering switch live in? Yeah, 172.16 network. You're absolutely right. VLAN 172. You're absolutely right. Excellent, excellent, excellent. All right. If I'm not mistaken, my camera is not showing, correct? Somebody let me know. I want to make sure that I'm right about that, just to be on the safe side. I know I'm showing screen. We're doing right. Okay, correct. No camera working. Okay, cool. That's how it should be, because again, you wouldn't be able to see the screen very well if I did shares. Okay, so global configuration mode. Which interface is it? Do we got to stick this IP on? What was it again? Interface VLAN 172. Very good. It comes up immediately because we have other interfaces already using that VLAN, that layer 2 broadcast domain. IP address 172.16.0. Who's fastest? What IP is it again? 253, 254. God, Scott's stubborn. He's like, no, it's 253. No, it's 254. Which is it? I got you doubting yourselves. Give me a firm answer. Which one is it? It's the LAN switches. What do the directions say for the LAN switches? Get the last available address. 255 is not available. Yeah, we tricked you. We are doing engineering. We are not doing aggregation. We did accounting. So the 3 LAN switches, the ones that actually have just those LAN segments, last available address is 254. We're confusing you. My apologies. Yep, 254 is the right answer. This gets 254, this gets 254, this gets 254 in their respective subnets. Aggregation gets the next to last available, which would be 253. And that's where the confusion popped in. And then it gets even better when we talk about engineering server. But let's not go there yet. Let's stick to our guns here. So 254.255.255.0. And if I do show IP route, we'll see that we don't have a default gateway. So let's go ahead and set that now. You'll notice I exited out of interface configuration mode just to make it easier so I can use that context sensitive help. And it isn't until I type IP default -G that it's even a unique command. There's a bunch of choices. Default. See, even then, it still could be default gateway or default network. We're going to use gateway. And it just give me the IP address of the gateway. And you folks already know it's the .1 that lives up on the router. The router is the gateway for everything to get to the rest of the universe. So now when I do my show IP route, I have a default gateway, know how to talk back. And then let's go to our line VTY 0 through 4 and say, hey, let's do transport input. All we care about is us, people trying to get to us. We're not worried about outbound connections. Telnet. And then I think we had to have a password. We used Cisco last time. That's the Telnet password, not the password to all other things in the universe. So real quick, we'll just test our connectivity from 0.254 from the router. Yep, it got into something. If I can't type here, CISCO, CISCO. There we go. And we're in an engineering switch. Sweet, it worked. And Scott is sticking to his guns at 253. It's not 253, man. It's 254, I promise. Let's see here. So engineering is working. Let's do IT. I'm moving a little faster. 1, because it's repetitious. We've done this a couple of times. And 2, because I want to be mindful of time. We still have some other activities to tend to in this assignment. I don't want to miss it. Oh, I did that to myself again. I'm used to typing end so much that when I go to type enable, it confuses itself. Configure terminal, interface VLAN. Which one is it here? I'm lost. Which VLAN? 10, yep. Thank you, Scott. Thank you, Steve, and everybody else that knew it and just didn't say it. I'll throw an IP address on there. Whoops, not DHCP 10.0.0.254. All the same size subnets here, which is super convenient. And let's do IP default gateway 10.0.0.1, because that's the one that lives on the router. The router is everybody's way to get to the rest of the world. And then line VTY 0 through 4. Whoops, apologies. Transport input telnet and password Cisco. Best practice is not to use Cisco for your password. I suspect you knew that. All right, so we configured that bad boy. Let's try to telnet to 10.0.0.254, which should be the IT switch. Something answered. Yeah, 1, 2, 3, 4, 5 is just as bad. And we're in the IT switch. Sweet. All right, victory. So, got management addresses on all 3 LAN switches. We still need to put a management address on aggregation switch. So let's do that now. Go away. You come here. Put this in the corner. You certainly don't have to arrange your windows this way. For me, I always like to see my picture of my network topology and all the windows I care about. It's just my habit. You probably have a better way of doing it, and certainly stick to your best way. There's nothing wrong with that. I'm going to enable, and let's see here. Show VLAN brief. You'll notice we have this default VLAN. We have the VLAN 10, VLAN 172, and VLAN 192. So lots of choices here. Which VLAN are we supposed to be using for ag switch? Oops. 172 is correct. So interface, whoops, VLAN 172. Remember, VLAN 172 is a layer 2 construct. It's about broadcast domain. It's about MAC addresses. We're saying, give me a place to have an IP address that lives in this broadcast domain. It comes up. We assign an address to it of 172.16.0. What is it, Scott? Dylan said, ask Scott. What a bunch of comedians around here. 253 is correct. Absolutely. The law of averages say you have to be right eventually. So let's do the same thing, though. We need the same default gateway. We need the same transport input telnet, our password, all that fun stuff. IP default gateway of 172.16.0.1. It's still the router. The router's still our way to the universe. And let's do line VTY0. And one thing I'll point out to you, we were in interface configuration mode. I've done it twice now. I don't know if you caught it. And I typed a command that was not specific to interface configuration mode. But because it was a recognizable command in global configuration mode, once I entered it, the switch said, oh, you must want to be in global config mode since you typed this. So I'm just going to drop you into global config mode. So it's a bit of a shortcut or a cheat. But you got to type it right. And you don't have context-sensitive help when you're doing those commands because it thinks you want context-sensitive help for interface configuration mode. So it's a bit of a shortcut. It's something you'll do as you get more familiar with it. Not a big deal at all. But let's see, was it line VTY 0 through 4, transport input telnet, and let's give it a password. And let's test to make sure we configured it correctly. So telnet to 172.16.0. Whoops, got to learn how to type. 0.253 this time, and something responded and asked for a password. It does this to me every time because I type poorly, and we're actually in ag switch, so victory. Okay, excellent. So we've done that. Let's look at these directions again. Last available for the LAN switches, next to last available in VLAN 172 for ag switch, and the second to next to last available address for engineering server. Sorry, I got distracted by a message. I apologize. So engineering server needs an IP. Again, we talked at the beginning about, or at the beginning of this particular lab about, we're going to do a static as opposed to DHCP. We could totally do DHCP, but we're going to do a static because it's a server, and that's considered best practice. So what IP address goes on Fast Ethernet 0 on this engineering server 1? I can move this out of the way if you need to see the directions or instructions too. I'll move my router off to the side. Steve says 172.16.0.252. Does anyone else have a thought? Scott's like, I'm good. I'm not saying crap. Jeremy's like, yeah, 252 looks right to me. Yeah, absolutely. That's the second to next to last available. It's the next one as we work our way down from that 255, 254, 253. It was the best way I knew to say it. And again, I was kind of half intentional about it because it makes you think. So 172.16.0.252. It says, oh, you're using, if this were classful addressing, that's a /16 or a class B address, so I'll set it for you. But of course, we know that's not right. In our universe, we have subnetted. that /16 to be a /24. We kind of chopped it up into smaller pieces. So cool, we've got that on there. Is there anything else we need to do for the IP address stuff for engineering server, or are we good to go? Yeah, Jeremy's like, well, don't we need a gateway? Yep, gotta have a gateway. If we never give it a gateway, it can never communicate with anything outside of its subnet. And the instructions actually gave us some things that it would need to communicate with things outside of its subnet. So let's throw that gateway of 172.16.0.1 on there. And yeah, we'll go ahead and stick the 68.188.0.2 DNS address on there as well. That's what we use on everything else. I think I'm right. Let me double check. Yeah, everything else is using .0.2, so cool. So engineering server's got IP address, it's got a gateway, it's got DNS. They're all statically configured as opposed to DHCP. If we'd have thrown DHCP on there, it absolutely would have done it. It probably would have grabbed like .5 or .6 or 7 or something like that. We need it to stay the same every time, so we're going to use that 252. All right, so engineering server is set. Let's see here. Aggregation switch, LAN switches, engineering server. Next step, don't forget to remove all static IP addresses from the DHCP pools issued by the router. Oh yeah, we got to do that. How do we do that? Does anybody remember how we did it before? Because we actually did that before. When we built these DHCP pools, we excluded all of the gateway IPs for each VLAN because, exactly right, Dylan, because we don't want to accidentally give out .1. Router's already using it. There are some other mechanisms in place that keep it from doing that, but you still always want to specifically say, hey, don't give that out. Don't give that out. So let's do some more don't give that out so that our management addresses don't ever accidentally be given out. So configure T, and it's right in front of us. The syntax is right there. Super easy. So IP, DHCP, exclude address, and let's exclude 192.1. So I'm going to work my way from left to right. .168.0.254. Don't give out 254. Accounting is using it. Accounting switch is using it, I should say. And let's make sure not to give out 172.16.0.254 because engineering switch is using it. And 10.0.0.254 because the IT switch is using it. And 172.16.253 because aggregation switch is using it. And 252 because the engineering server is using it. We won't ever want to give those out. That's a little inefficient to type every single address. There's another way to do it. We could do IP DHCP. Yeah, Steve's already on it. Can you do an excluded range to save some typing? You're exactly right. Of course you would. And you could just say, instead of one IP, you could say 172.16.0.252. And the space bar, what's the high end of the range, which would be 172.16.0.25. Whoops, 0.254. It is a little bit faster, and it's also best practice. If you know you've got a block, it's very common. If all of your LAN segments, or typically your LAN segments, have some amount of static IPs, it's very common to pick one end or the other of the spectrum for your statics, or maybe you always do 100 through 110 for your statics. It just depends on your architecture, your schema, your particular way of doing it. So it's pretty common. That's why range makes a lot more sense. So yeah, I think I've probably done it redundant here. Do show run. Yeah, it's totally redundant here. I've got it here, here, and here, but I've also got it here as the range. It's not hurting anything to leave them like that. It's just messy and sloppy, but know that you have either option, so cool. So we've done that. We've made sure they don't accidentally get given out. Now the only thing left to do is configure all switches and routers to send logging to the syslog server located in the engineering LAN. Well, Eng server is supposed to be, according to this, FTP and syslog functions. So first of all, let's go in here and make sure that this actually is operating on that service. It's not supposed to be a web server, so we'll turn that off. It's not supposed to be a DHCP server, so that's off. Same with IPv6. It's not supposed to be TFTP per se. We'll turn that off. It's not a DNS server. Make sure that's off. It is supposed to be a syslog server. Okay, cool. So that's on. That service, it's listening on the appropriate port for syslog to receive syslog messages and write them down. It's not supposed to be doing any authentication or any of those things. It's not a network time server. It's not an email server, so we're turning all those things off. It's supposed to do FTP, so we'll leave that on. and registration, and it's not supposed to do any kind of virtual machine management, and it's not supposed to do any kind of extensible authentication protocol. So the big thing that matters is that syslog and that FTP, and we have them on, and we're going to check that syslog action and make sure it really works the way we think it works. So let's start with the router. How do we send syslog messages to show logging? Logging has no messages in there. How do we do that? Yes, Dylan was like, okay, let's see, turn on some logging. So logging on. If you turn on logging, it should be able to log. And then also, we got to figure out where do you send it to. So if we say logging, like we just did, and then we say, okay, who's logging my stuff? Who's going to track all of my log messages that come out? Where do I send them to? Got to give them an IP. Well, what's the IP address of the logging server? Oops, got to say logging first. Logging 172.16.0.252 that we spent all that time talking about. Great. So, all right, as soon as I come out of my global configuration mode after setting that, it says, okay, I'm turning on my logging service, message level 6, and I'm sending log messages to this address, that 252 you gave me, destination port 514. It's all turned up and ready to go. So let's put router away for now, pardon me, and let's grab aggregation and just do the same thing. It should be exactly the same syntax for these particular, if I can type, these particular models of routers and switches. So logging on and logging 172.16.0.252. So Dylan brings up a point. Do we need to turn on some services? Yeah, absolutely. In general, you want to be very specific about what it is you want to log into your own log that lives on the device and what you want to send. And it can get very convoluted and very tricky and very complex. So for the sake of this exercise, we're not going to turn any specific service on, but we are going to test that we get some kind of logs building in there. But yeah, you're absolutely right. There's really you have to be very thoughtful about all of the things you want to send, because frankly, you only want to log the stuff you care about, which is a lot of stuff. But you don't want to fill up your logs with junk that is never useful and never helpful. And you only want to send to your syslog server the things you know you want to preserve. Generally, everything you want to put in your log on the device, you want to send to a syslog server, because once that device reboots or explodes or whatever happens to it, its coffee gets spilled in it, you may lose those logs. That's the whole reason we send them to a syslog server, so we can preserve what was ever coming out of that device for the logs. But maybe you don't want everything. It just depends. It depends on what it is important to you. Do I want to see interfaces going up and down? Do I want to see VLANs doing certain things? Do I want to see error messages of certain types? Just depends. So because it is a very complex topic, we're not going to dive into it here, but suffice it to say, it's something you do want to consider. So, all right, so we got the logging turned on, and as soon as I leave global configuration mode, it's going to say, okay, I'm officially sending my logs now because you told me to. And let's do the same for accounting. Configure terminal, logging on, logging to 172.16.0.252. And I'm logging because you told me to. Notice it wasn't doing it until we actually exited global configuration mode. Config T, logging on. You notice I start typing in shorthand when we get, moving pretty fast. Again, you will all eventually do the same if you don't already. And come over here. Config T, logging on, logging to 172.16.0.252. Cool. Now, question is, how do we make sure logging things got to the logging server? The syslog server is essentially empty. The log is clear, there's nothing in it. We have to make something happen that would trigger an event that would hit the log. So on router 0, actually, let's pick a different one. On IT switch, why don't we turn off this interface that's facing PC8 just to make something happen. So that's fast Ethernet 0/3. Steve asked a question, would ping cause a record? No, in general, ping would not. Just pinging from something to something, even like from IT switch as an example, it's not something that is log worthy. It's typically something you would never, ever track. It may be possible, but frankly, my gut says it's not. But I've never seen it done. It's not a particular example, but it's a good again, good thought. You want to think through it. Jeremy basically said, look, you change something, make a change, it should log it to some degree. So let's do config T, and let's go interface fast 0/3, and let's just shut it down. And you notice it turns red on the board here because it's completely shut down. Poor PC3 is, or PC8's cut off from the world because we're mean. And then we can no shut it. It's back up. And you'll notice that he turned green right away, but he said, I'm going to be amber for a while. I'm not quite allowing traffic right away. I think we covered that in the last lab or the one before. Does anybody remember why IT switch doesn't immediately allow traffic to start forwarding on that interface? And to your answer, Steve, yes, mostly a state change like that. That's exactly right. Something that's more meaningful from an event perspective. Yeah, Steve's right. Spanning tree, Jeremy, you're right. Spanning tree. Spanning tree protocol as a protection mechanism against bridging loops, or bridge loops, puts a hold on traffic being forwarded immediately unless we tell it to forward traffic immediately, which we have not configured the internet or our network to do that. So we did some stuff. We turned something on, we turned something off, and we made a config change. Let's see if level 5 syslog messages in fact get logged in engineering server. Boom, look at that. Wow. So we have no timestamp, but from logging from host 10.0.0.254, which should ring familiar to us as the IT switch, it noticed we configured something. It noticed we had a line protocol, something up. Fast I had to double click it to get to the message. Fast 0/3 changed to up, changed to up, changed to down. So this is in reverse order. Yeah. So somebody admin down fast Ethernet 0/3, then it went completely down because someone admin downed it. It's a poor use of grammar. I apologize. And then it came back up, both the interface physically and the line protocol, or layer 2, so to speak. And then lastly, somebody essentially exited out of configuration mode, and they did it at the console. So I would say syslogging activity is happening. It seems to be working. So that's a good sign. All right. That covers everything that we had in both of our 2 labs that we were going to do today. Timing actually worked out pretty decent. Does anybody have any specific questions? Anything we did that didn't make sense? Anything you're concerned about? Oh, you're welcome, Dylan. You're absolutely welcome. I'm happy to share. Hopefully we can do a bunch more of these. I appreciate it, Scott. Thanks, Jeremy. So, good question. So why didn't the log file have timestamps? Essentially, it's because, let's do a show clock. We have essentially an unconfigured, unconfirmed clock on all of our network devices and all of our devices in general. We don't have a true source of truth for time, and lacking a true source of truth, the devices don't report their time. And that's essentially what it means. When you say show clock and you get that star, it basically says, I don't really know anything about network time. I don't know what time it is really. No one's telling me. So if I do a show NTP associations, there's nothing. If I do a show NTP status, there's nothing. There's no network time protocol enabled on any of our network devices, and there's no thing out there on the internet or in our network acting as a source of truth for network time. And so lacking a source of truth, it doesn't even go to the trouble to tell you what time it was when it happened. Yeah, they don't even know if they agree on what time it is right now. And actually, you raise a good point. Without the timestamp, that syslog buffer is just about short of useless. It's not completely useless, but it's really close to useless. You would never have any production network anywhere that you didn't have some form of network time, whether it's because you had a specific time server set up or you picked a specific device, say router 0, to say, hey, I'm going to tell you what time it is. You be the source of truth for everybody, and you keep track of time for everybody. That's also not uncommon. Or maybe you'll find a source on the internet that is a true source of time. There's actually multiple places you can go for atomic clocks and things like that, and some networks use those as source of truth for time. So lacking it, they don't even attempt to tell you what time it is because they know their time on their clock is worthless. As you can see, it thinks it's 1993. I will bet you Monday, March 1st, 1993 is probably some seminal date in the history of Cisco systems. That's my hunch. That's probably why they picked it as the beginning of all time in the universe. I don't know. So any other questions? Don't do not apologize for sidetracking. It's the questions and the interaction that make this worthwhile. Otherwise, I'm just talking to myself. I can record that and play it back for you as opposed to the interaction. So I appreciate the interaction. It's not uncommon for me to be the only one talking. So even though no one actually spoke up, it was good to see all the questions and stuff. This is the most that I've had since we've started these. So I really appreciate it. Okay, everybody. Thank you so much for your time. Sure thing, Dan. We're going to keep putting them out there. I don't know if we'll get any more in this year, but 2021, we'll do some more of these, whether we pick the series up from where we're at now or we start over. Don't know yet. We're going to sort all that out. Maybe we just play recordings of the first three. We'll sort that out, but we'll keep them rolling. My goal is to get folks who live in this cable business who are, maybe they're not network and IP experts, getting to the place where they're comfortable and would consider that maybe their career takes a turn in that direction, or maybe they're just starting in the direction. This is just help building, fortifying the foundation and stuff. This is all considered, everything I'm doing in this series is really about doing kind of network 101 and because just like me, I'm just want to give everybody a chance that's interested to go into that side of the business if that's where their passion or their desire is. I got very lucky. I came from the field and ended up doing this for a living, so I want to pay it forward as much as possible. All right, thanks everybody. I appreciate it. I hope you have a great Thanksgiving or holiday or whatever you're going to be up to over the next few days. Be safe, take care of yourselves, and we'll catch you next time. Thank you so much. Bye.